Well, good morning, Algebra 2. We are getting ready to start another chapter. So today we're working on chapter 7, and we're going to do sections 1 and 2. We're going to be working with exponential functions and logarithmic functions this chapter. Those are some new words to you, and let's just kind of look at what we're doing. First is exponential functions, and notice this is the first time that we've seen a variable as an exponent. So let's talk about what that looks like. Anytime we have one of those, okay, our parent graph is going to look, and I apologize, that is a really rough looking graph. Okay, so anytime we have an exponential function, let's talk about what the parent function is going to look like, the parent graph. It's going to start down here really, really close to 0, and it's going to come up. And that is going to go through the point 0, 1. Okay, so regardless of what it is, unless we're really changing some stuff there, this is what the parent function is going to look like. Okay, and let's talk about a couple things. Number one, on the left side here, that is going to get smaller and smaller and smaller and smaller and smaller all the time, and it's going to get closer and closer to 0, but it is never going to touch 0. It'll never touch that line, y equals 0. That is called an asymptote, all right? If the line that it never touches is called the asymptote, and it's never going to touch 0. Now, on the right side over here, that is going to get almost vertical. It's going to go up, and it's going to keep getting straighter and straighter and straighter, almost straight up and down, but it's never going to get there. It's always going to continue to get bigger, okay? So going through the point 0, 1, never touching the asymptote over here, and it gets bigger and bigger and bigger, but it will never go vertical. It's always gonna stay getting bigger. All right, so let's go ahead and sketch this graph. So to sketch this graph, y equals 2 to the x. Again, going through the point 1, 0, and it's going to be real close to 0 down here and come up like that. And I apologize that I can't draw it better. I'm having trouble annotating this correctly, but you can see that it's real close to 0, doesn't touch it, always going down, and then just curves up. Let's talk about number 2. Number 2, once again, it's exponential. So it's going through the point 0, 1. So it's going to start down here very, very close to 0 and come up and go up like that. All right, now the only difference that you can see here is that in number 2, my graph is a little bit steeper, and the reason it's steeper is because that 4 is bigger than the 2. Okay, so the bigger that number, the bigger the base is, the steeper that is going to be. All right, let's look at number 3. Now, number 3, we are introduced to a new concept, E. E is a very important number, and we'll talk about it more later, but it's going to be the number about 2.7 something, all right? And so let's just graph this. It's going to be the exact same as it was before. It's an exponential function, so it's going through the point 0, 1. The asymptote is y equals 0, and it's going to curve up like that. All right, there we go. Pretty easy. Now, this one is pretty tricky, all right? This one, if the base here is a fraction, if it's less than 1 or the absolute value is less than 1, then what's going to happen? It's still going to go through the point 0, 1, but if this base right here is a fraction, if the absolute value is less than 1, it's actually just going to flip it. It's going to reflect it over the y-axis just like that. All right? So now let's talk about the next ones. The log of x. Well, this is just the parent function. All right? And the log is actually the exact opposite of a square root. Okay? Or, I'm sorry, not of a square root, of the exponents that we just did. The opposite of the exponent. So right here with a log, it's going to go through the point 1, 0. It's going to have a vertical asymptote right here where it gets closer and closer and closer to 0, but it's never going to touch this. It's never going to touch the line x equals 0, and it's just going to go up. Never touches x equals 0, goes through the point 1, 0, and it curves across like that. Number 6, this is a natural log. A natural log is the exact same thing as a log. Well, there's only one teeny tiny difference, and we'll go over that later. But for right now, know that a natural log and a log are the same thing, okay? Especially when it comes to their graphs. Their parent graphs are going to look almost identical. Going through the point 1, 0, very, very close to 0. It's our vertical asymptote right there, and curving across. All right, notice it kind of looks like a square root function, that curve up on the top, pretty close. All right, y equals the log of x base 3. Once again, going through the point 0, 1, and since it's a log, it's just going to look like that. Okay, now we'll talk a little bit more later about ways we could sketch them a little more precise, but for a sketch, that's basically all we need. Okay, sketch a graph of each using transformations. Well, okay, so let's look at this parent function. So remember what the parent function looks like. This is exponential, so it's going to look like that going through the point 0, 1. Okay, but now we've done transformations before. We know what this does out here. That is going to scoot it up 1. It's a vertical transformation, a vertical translation going up 1. So our new graph is going to be the exact same thing, and it's going to go up 1. Now, instead of the asymptote being at 0 like it was before, now the asymptote has moved up 1, and the asymptote is going to be at 1. So our graph is going to look like this. Okay, and it got a little rough, but you can see. So blue was our parent graph, our parent function, and red was the translated one where we translated up 1. All right, so number 10, this translation is going to be down 3. There's going to be a vertical stretch of 4. It's going to be a little bit steeper, but the big thing here is that it's going down 3. So instead of being at 0, 1, if we go down 3, it's going to be 0, 0, 0, negative 1. 0, negative 2 is where our new graph is going to kind of start. And so if we go down 1 from there, that will be our horizontal asymptote coming across and going up. All right, so that's really not all that bad. If you look here, we can sketch this. First, let's do our parent function. Parent function is looking like that, right? But since we have a negative, that's going to flip it over the x-axis, right? So this just flips it upside down. So if the blue is our parent function, the red is going to be what this one looks like. All right? So pretty easy stuff, not bad. So over here, our parent function, that's really, really bad. Let me see if I can do that better. Our parent function is going to be right here. Okay, but we have a negative out front, which means it's going to flip over the x-axis. It's going to be down. And this number right there, remember that since the absolute value of that is less than 1, it's going to actually reflect over the y-axis as well. So if we flip it over first, we flip it over the x-axis, that's what it looks like. And when we flip that, when we reflect that over the y-axis, that is what our final one is going to look like. So this first flip right there, that's because we have a negative out front. The second flip right there, going from there to there, getting to the blue, that's because that number is a fraction and it leads to a flip over the y-axis.